Andreas Forsland joining us, who is the founder and CEO of Cognixion. Cognixion builds accessible and affordable neuroprosthetic software and wearables that use biometric sensors and machine learning in new ways to help people with complex disabilities, which obviously is amazing work. Now, I'm just going to bring up Andreas to come and be able to speak with us, so he should be able to join us.
Excellent. Thanks, Phil. And thanks, Dave, for that wonderful opening keynote. I'm absolutely blown away by everything that you shared. So thank you. And I'm humbled to be able to follow you on this talk today. So I wanted to introduce everyone here to the work we've been doing at Cognixion. My name is Andreas Forsland. I'm the CEO and founder of Cognixion. We've been in business since about 2014. And like Phil said, we've been focusing all of our attention on bringing advanced technology to bear to support individuals with complex disabilities, ranging from speech or motor disabilities, to be able to access the world in faster ways. So when we think about the I/O, or the input-output interface, we're trying to transform that to a new kind of I/O, which understands your intention and your outcomes and tries to shrink the amount of time it takes to be able to accomplish something, whether that's communication or controlling your environment. So just as a quick aside, a point of inspiration, for those of you who are movie buffs, you might be familiar with a film called The Diving Bell and the Butterfly. And it's about a Frenchman who was the editor-in-chief of Elle magazine. He's 43 years old, a gentleman named Jean-Dominique Bauby. He was living the highlight of his life. I mean, an amazing, epic lifestyle. Had a great family and just about everything you could imagine, and life was going really well. And the movie was actually an autobiography, so he was telling his own story. But as he was driving through the countryside with his son, there was nobody around, and he had a brainstem stroke, and it was catastrophic. He was able to be transported to the hospital, but when he arrived to the hospital, pretty much everything in his body had shut down except for one eye. So in the course of his admission, they had to sew one of his eyes closed so that it wouldn't dry out. And then the rest of his living life, he worked with a speech language pathologist to rehabilitate his ability to communicate through blinking through one eye. So you see on the photograph on the right, that's his speech therapist. And she has what's called a letterboard. And as she's holding the letterboard up, she is orally going through every letter in the alphabet. And when she hits a letter that he wants to keystroke or type, he has to blink his one eye in order to do that. So Jean-Dominique, he actually wrote his entire screenplay for this film and the book. Which is phenomenal, just through eye blinks and his speech therapist. So if you think about the outcome of that, his new normal is entirely different than the normal that you and I may be living with. And when we think about how things may arrive that you're not expecting, whether that's a congenital birth of a child with a disability, or you might have something like this where you have a stroke, or you might have a progressive disorder such as ALS. Things happen and things change, and ultimately you're not necessarily prepared for them. And the world doesn't necessarily have the technology in place to be able to accommodate all of the needs of individuals with these kinds of disabilities. So just take a moment and imagine what it's like to not be able to communicate. Even just basic needs are being able to say the words yes or no. Now imagine you're in that state and you can't communicate yes or no with your mouth orally or through body language. But what if you could actually go one step further and bypass your mouth and be able to have a direct brain interface to do things as audacious as being able to physically open the door with your mind? So those are the wishes and desires of the folks that we work with. So there's over 1 billion people worldwide that have some kind of neurological disability that affects their vision, speech, hearing, or motor capabilities. There's a strong overlap between people with speech disabilities and motor disabilities. Roughly 500 million people in the world meet those criteria. If you think about that in perspective, imagine the entire population of Canada, the United States, and Mexico and even a few other countries thrown in. Imagine every single person is unable to speak. How would you get along? How would you communicate or get things done? Just take a moment to take that in. So like I said before, these are our children, these are our friends, these are our colleagues, they're not statistics. And so if you think about this, what would you do if you could actually control things with your mind? So this isn't a new idea. It's been around for decades. The idea of connecting a brain-computer interface to a system that would allow you to control things. Billions of dollars have been spent in the laboratories to try and figure out how to get good quality signals out of the brain without surgery, and try and find a way to pipe that data through a network to be able to control systems, whether it be desktops or other things. But right now, it's a complicated affair. There's lots of moving parts. It's a bit of a Rube Goldberg situation where people have to DIY these solutions. And there's not yet been a closed loop system that actually pulls it all together and integrates the BCI and a display and the software and the operating system into a single package that would enable the world to quickly get up and running in those times of change when things unexpected arise. Until now. Today's the first day that we're presenting a public viewing of what we're working on regarding the combination of a brain-computer interface combined with an integrated augmented reality headset in one system. And we're calling it Cognixion ONE. And this doesn't just allow the computer to say hello, it allows the human to say hello. It's the world's first integrated brain-computer interface, like I said, that combined with augmented reality. And what's really important here is there's been work done with virtual reality, but there hasn't been anything like this produced for accessibility or for assistive technology. It's truly a new kind of window to the world for the individual regarding the types of augmented reality overlays and interactivity that they can now have with the world around them, with the people around them, with the systems around them. And because it's a clear lens, it's an opportunity for the world to finally get to know the real person, the real you who's unable to communicate, whether that's a teenager that's nonverbal with autism, or an individual with cerebral palsy that might be misunderstood, or an individual with late stage ALS that wants to simply be able to turn on and off the lights or initiate the Roomba to go and clean the living room. It's finally a chance for people to be able to be recognized as a human and be able to share their ideas and be acknowledged for what they have in them. On the BCI side, what we're doing is we're extending abilities to the most vulnerable. What it includes is a tunable brain-computer interface that's designed to detect not only visual, but also auditory and haptic stimuli or evoked potentials. And it contains 6 channels on the visual cortex with 2 auxiliary channels that could be routed to any other place on the body, whether that's your electrooculography through the eyes or EMG through some other part of the body. All of that can be centrally managed and consolidated through sensor fusion and processed locally on this brain computer. So what we're thinking about is not just providing freedom for the individual to move, but actually letting their ideas move the world. So for some individuals, simply being able to turn on the lights, listen to news, order food delivery like Grubhub or DoorDash, or for some people being able to actually give a TED Talk, and other people being able to go and get your first job. This is life-changing, and it's a huge social impact by being able to provide this kind of technology to so many people around the world. I'm going to show a couple of examples here in videos. One of these videos is of a gentleman in Canada. His name is Professor Manelli. Like Jean-Dominique Bobby, the story I opened with, this gentleman had a double brainstem stroke, rendering him completely paralyzed. It took him years to do basic rehabilitation so he could move his right arm and have upper neck strength, but he's unable to communicate verbally. Prior to his brainstem stroke, Professor Manelli was a professor of Old English literature and spoke fluently 9 different languages. Could you imagine being able to speak all of those languages and then now your mouth doesn't work? So by providing him with our early alpha test versions of our system, he was able to actually go back and start to compose lectures, and he delivered his first 45-minute lecture using our system to the March of Dimes in Canada. I'll show a little clip here for you to see that.
Profit then closed their website and disappeared, so that they can't even be reached, and we have lost hundreds of dollars and are left with a useless app and no access to our files. Caveat emptor, buyer beware. Medicine is an art as well as a science, and a great art requires a great imagination and a capacity for empathy. Take the opportunity to see your own suffering in the suffering of others, for when you can see others' suffering as your own, you will be greatly rewarded.
Professor Manelli, thank you.
Further, now that we've been able to digitize and make digital all the biosignals, the world is really open for ideas as far as what kinds of systems we want to control. So there I showed a demonstration of Professor Manelli controlling an augmented reality application on a heads-up display. Here's a video of one of our engineers in Toronto demonstrating the remote control of a prosthetic hand.
Wearing an AR headset, and on the headset are some little circles that are flashing. The EEG is being recorded through some electrodes on my scalp, and through that we're sending it through some machine learning algorithms that are then determining which part I'm looking at and changes the position of the hand. So right now I'm looking at number 4 position, which does this with the hand. Now if I move to number 3, it does it almost instantly and changes to 3. Now I'm moving over to 2, and finally 1. And that's all there is to it. It's pretty fast, pretty easy, and yeah.
So what I wanted to also share is to build a startup that's doing this kind of system integration, this kind of engineering and scientific work. It requires us to think about all aspects of the business model. And one of the things that we've done to de-risk the business model and establish a path to market for this technology has been to develop a large and growing network of relationships with speech language pathologists and neurologists. And we've also been focusing on software and not hardware. So one of the things that we're providing in December, we're releasing a version of our application onto iPads or through the Apple App Store. And the app will have predictive keyboards, several different predictive keyboards for different kinds of usability needs. And those predictive keyboards also contain a deep integration with Amazon Alexa. So the Alexa service, anything that you can do with an Alexa skill, you'll be able to directly access through our language access interface. So this allows people to say what's on their mind. They can send what's on their mind to Alexa to execute any skill, whether that's tell me the weather or ordering food, opening the door, turning on and off the lights, and also the ability to save and store expressions for future use and customization for rate enhancement so that they can communicate at a much more fast rate, nearing that of text messaging or even verbal communication in some cases. So why that's important is that the work that we're doing here on iOS is going to be able to port into the augmented reality environment so that the individual can control a 3D spatial version of this technology using their BCI in the headset. So if you think about individuals in the community that have made a huge impact through their ideas and have beaten the sort of inertia of marginalization for people with disabilities, individuals like Stephen Hawking, we see a new generation of thought leaders that are starting to rise up and share their ideas, whether in the written word and publishing books, or even in the case of public speaking. And their voices are starting to be heard. So the next generation of the next 10 to 20 years, we believe, is going to see a sea change in inclusion and universal design and social integration. So 2 weeks ago, I shared the stage on TED with a gentleman named Tim Jin, who has cerebral palsy. We had a really great fireside chat going back and forth, and Tim was using our application with the Alexa integration for the entire presentation. Tim can't control his arms or his body. He has spastic CP, but he is able to type with his toes. So if you want to go online and check out that video, just Google Tim Jin TEDx, and you'll be able to see the full interview. It's really exciting. So where are we going as a company? So what we've been building this as one platform, and there's many, many use cases. In 2021, the technology is going to be available. We're going to be bringing it to market with some additional news that we're going to be releasing over the next couple of months. But we're initially going to be releasing it through the research channels for universities and corporate research laboratories, physiological labs. It's going to be positioned with existing research workstations that 99% of universities already have through a deep API integration with our headset. As well, we're focused on the assistive care market and providing this as a fundable device through insurance, specifically as a speech generating device that can provide environmental controls. So in 2021, we're going to be offering the solution to healthcare organizations such as ALS units and healthcare organizations and associations, as well as private customers. And we're aiming for the device to be covered by insurance in 2022. So as you can see, this is really just the beginning. So it's an area of opportunity that brings a lot of complicated things together into a simple package. It allows researchers and scientists to access this as a platform. It allows development to be able to create interesting, unique applications, ranging from control applications to anything that you might be able to imagine controlling through your BCI. So in closing, we launched a new app called one.cognition.com. And if you'd like to go check it out, it provides a lot more deep information about the technology. If you have specific technical specification questions, I would direct you to go to one.cognition.com. There you can also join our early bird pre-order list for getting early access to the technology. If you'd like to write about this or learn more or share this with your communities, you can request an interview or media assets. And what I didn't mention is that we have a user and clinical expert advisory council of around 100 people, and we'd like to grow that even more. And so those are individuals who could potentially be power users of this, and we'd like to take your input as we're finalizing the product for production and our first release next year. So with that, I'm opening it up to questions.
Great. Well, Andreas, if you could stick around, we'll ask questions at the end of the session today, but that was really fascinating. And I was involved in control strategies in bionics back in the noughties. So seeing your colleague there controlling the hand, that was fascinating. Unfortunately, the sound wasn't playing through. So perhaps could you just explain what your colleague was doing when she was sharing that demo with us?
Absolutely. So one of the things that we've been trying to do is to try and get as much signal out of as few electrodes as we can, right? And so what she was demonstrating is with just 3 electrodes, she was demonstrating the use of SSVEPs as a control interface and being able to associate different holographic objects with different hand movements. And so based on the hand movements she was fixating upon, it was sending that control signal out to the connected hand. So she was demonstrating that, when she's concentrating or fixating on, one finger, then the robotic finger within 1 second. So this is around the latency that we've been focusing on reducing the time envelope for intention to outcome. And we've been doing that by a lot of the consolidation of bringing all the electronics into a single package. But rather than using CECA, starting to move more into machine learning models and running neural nets on the system itself so that we can help shrink that amount of time required to be able to have very, very high accuracy and very fast, reliable signal detection.
Interesting. And presumably my experience is in myoelectrics. So with these surface mounted electrodes that were giving the three of those, giving those the signals.
Yes, they're passive dry electrodes using silver chloride tips. So we've been doing a lot with pretty noisy, we've been kind of going into the extreme edge case of how much can we do within the noisiest of environments.
Well, fascinating work, Andreas. Well, we look forward to sharing some questions with you later. So thanks very much for your presentation today. That was really amazing.
It's my pleasure. Thank you, Phil.
Great. Thanks for your news today as well.